So now we're going to go over the quotient rule. Now the quotient rule says, sorry, wrong color. Let me get out the right marker. There we go. So the quotient rule just says, if a and g are differentiable at x, and g of x does not equal 0, then the derivative of f over g at x exists, and the derivative of f of x over g of x equals g of x times f prime of x minus f of x times g prime of x all over g of x squared. Now in red, you're going to see that I put in the brackets there, and that's because, number one, the book doesn't show you that, and number two, when you have a function f of x and you multiply it by another function g prime of x, you may end up with a function that's expanded with multiple terms. And what you do not want to forget is that you have a minus sign right there, and if you are simplifying this, you got to make sure you distribute that negative sign or that minus sign to every single term in that second part of the numerator. So if you just put everything in brackets, you'll never forget that. So I have a pretty easy example here. Notice it says set up, do not simplify. So all we're going to do is we're going to find the derivative of x to the third plus 3x squared minus 2 all over x squared minus 1. So the easiest way for me to kind of approach this problem is I'm just going to go ahead and just label what I need. So I'm going to let f equal x cubed plus 3x squared minus 2. And then f prime is going to equal 3x to the second plus 6x. Now, g is going to be the denominator, so that's going to be x squared minus 1. And g prime is going to be 2x. Now, like I said, these can get ugly very quickly, and you're going to see why just here in a second. So the derivative of f over g is going to equal, well, that's going to be g of x, x squared minus 1, times the derivative of f, 3x squared plus 6x. Put your minus sign in a bracket. Now this is going to be f, which is x cubed plus 3x squared minus 2, times g prime, 2x, all over g of x, which is going to be x squared minus 1, quantity squared. So, as you can see right here, first example, these get very, very ugly very, very quickly. So make sure you are just paying attention to the directions. If they want you to completely simplify, then you're going to have to completely simplify. And that's just one of the things you got to do. In this example, all I really wanted to show you is where does everything fit. Okay? Now the next example, the derivative of 2x to the fourth plus 2 all over e to the x. I'm going to go ahead and I'm going to show you how to simplify all this, because this one actually turns out to be very nice. It's just a matter of just keeping everything nice and neat. So, once again, f is going to be 2x to the fourth plus 2. F prime is going to be 8x to the third. G equals e to the x. Therefore, g prime is going to be e to the x as well. Now, our derivative for f over g is going to equal g times the derivative of f minus, remember, put that bracket there, f times the derivative of g all over g to the second power. Now to simplify this, d dx of f over g is going to equal 8 e to the x times x cubed minus, put a little bracket. Now I'm going to distribute the e to the x, so that's going to give me 2 e to the x, x to the fourth, plus 2 e to the x, all over e to the 2x. Actually, you know what? let's leave it as e to the x quantity squared. Oh, don't even know what that is. Sorry about that. Let's just erase this real fast. So our derivative is going to equal 8 e to the x to the third minus 2 e to the x to the fourth plus 2 e to the x all over e to the x quantity squared. And yes, you can further simplify this, because if you look in the numerator, every single term has an e to the x in common, so I can factor that out. And then lastly, I can go ahead and just reduce one of the e to the x's to give us 8x cubed minus 2x to the fourth plus 2 all over e to the x. And that's how we apply the quotient rule. Now, everything else in this section is just a review of everything that you've already done. So, for example, we could come across a problem that looks like this. Let's say given y equals 2x squared over 3x minus 1 with a equal to 1. Let's find the equation of the tangent line at the specific value of a. Okay? So recall, anytime you see those words, find equation of the tangent line. Remember, we need the slope at x equals a. In this case, it's going to be 1. We need a point. So we're definitely going to have to find our point here. And then 3, we're going to use y minus y1 equals our derivative evaluated at a times x minus x1. So let's go ahead, let's do it one step at a time. So first, let's find the slope, which we know the slope is going to be our derivative evaluated at 1. So in this case, it's going to be f prime of 1. So let me go ahead and just write this out. Because I'm going to be screwing up a lot here, so I just want to make sure I have it. So off to the right, f equals 2x squared. F prime equals 4x. G equals 3x minus 1. So G equals 3. Our derivative, y prime, is going to equal G times f prime minus, put that bracket, now that's going to be f times the derivative of g, which is 3, all over g to the second. Now, I would just simplify this a little bit. You don't have to get crazy with it, because here's what we know. We know we need to evaluate this at x equals 1. Like, we know eventually we're going to have to substitute in a 1 and figure out what this is. So the only thing I'm really going to do is just kind of just clean this up just a little bit here. 2 times 3 is 6. And really, that's all I'm really going to do. Now, I'm going to evaluate this when x equals 1. So, y prime equals 3 minus 1 times 4 minus 6 all over 3 minus 1 to the second. Remember, all you're doing is you're just substituting in 1 in for x. So 3 times 1 is 3, 4 times 1 is 4. 1 squared is 1, and 6 times 1 is 6, and so forth. So therefore, y prime is going to equal 3 minus 1 is 2 times 4 minus 6 all over 2 to the second. 2 times 4 is 8. 8 minus 6 is 2 over 4, or y prime equals 1/2. So there's my slope. But now we need our point. So if I scroll all the way back up here, check mark, I know my slope evaluated at x equals 1 is 1/2. Now the point, well, this is going to be y equals 2x squared all over 3x minus 1. So our point is going to be y equals 2 times 1 squared over 3 times 1 minus 1, or y equals 2 over 2, because 3 times 1 is 3 minus 1 is 2. So y equals 1. Our point, therefore, is 1, 1. And now that we have all that, I can go ahead and use the point slope form. And that's going to give me y minus y1, so that's going to be y minus 1 equals 1/2 times x minus 1. Y minus 1 equals 1/2 x minus 1/2. I add 1 to both sides. Negative 1/2 plus 1 off to the right. Now, like I said, I'm going to be really clever on how I write that 1. It's going to be 2 over 2. So negative 1/2 plus 2 over 2 is plus 1/2. And here's our equation of the tangent line. So if you kind of just, let me zoom out here a little bit. And if you just kind of go back to the beginning here. When you see the words find equation of the tangent line, you need a slope, you need a point, you need your point slope equation, and the idea behind it is the technique doesn't change. It's just now that derivative is a little bit more difficult to actually calculate, and that's because you have to use the quotient rule. My advice, make sure you just take your time and you write everything out, make the substitutions. If you can simplify the easy stuff, go ahead and simplify the easy stuff. If you can't, that's fine. Just evaluate it at whatever value they want you to. And that's going to be it for this video. So on the next video, I'm just going to go ahead and do a bunch of just examples of using the product and the quotient rule together. I'll see you in the next one.